Dear student, today I am going to start the lesson number 9, boxes and sketches of class 5 maths textbook. Here in this chapter, you are going to learn the difference between 2D shapes and 3D shapes. Let us learn what is 2D shape and 3D shapes. 2D shapes. Shapes such as a sheet of paper. The shapes which we can draw in a sheet of paper, or we can say in plain surface. The shapes have only length and breadth. So such shapes are called 2D or two-dimensional shape. You can see these examples: triangle, square, rectangle. These are plane shape, even circle also. This is a plane shape of curve. These are all polygons of straight lines. So 2D shape has only two dimensions, that is length and breadth. So you can see this is length and this is breadth, we can say like that. And even for circle also we can take a length and the breadth. So here for all this figure we have only two dimensions. So these shapes are called 2D shapes. Now let us learn what is 3D shapes. Shapes such as shape of a house. In our daily life, whatever things we see around us, like a house, even this pencil also, anything we see around us have length, breadth and height. They have three things: length, breadth and height, like these shapes. But in this shape has only length and breadth. So such shapes are 3D or three-dimensional shape. So these two shapes are two-dimensional, and this is called cube. You can see the face of this cube are look like a square. You can see this, all the faces of a cube are look like a square. So we get a cube from square surface. So here the edges join in the point. You can see this edge, this all edges joining in this point. So this point is called corner. So in this cube it has how many corner, or we can say vertex also: 1 2 3 4 5 6 7 8. It has 8 vertex. Vertex is also called corner. And this line you can see in this cube, these lines are called edge, and this is face. This all, you can see, these all are face of this cube. So it is cube. Now here we can see the three dimension. Suppose this is length. This is length and this is breadth. Okay, length, breadth, and we have a height here. So you can see it is height. So all three-dimensional shape or 3D shapes has length, breadth and height. They have three dimensions. So they are called 3D shapes or three-dimensional shape. Here you can see this is a shape of a cylinder. Here we have, this is flat face, and downside also one more flat face, and this is round part is curved face. There are three face in this cylinder, and it has two edges. You can see this is round part, this is edge, and here also one more edge. So it has two edges, three faces, but it has no corner. So this kind of shapes which has three dimensions are called three-dimensional shape. Keep in mind, we can make sketches or nets for all kinds of boxes. Boxes are 3D shapes or 3D shapes. That is why I am writing. For example, this is a 3D shape, which is cube. If we unfold this cube, then we will get a shape of this. So this shape is called cube nets. If you again fold this, then you will get the cube again. So these kind of things are called cube nets, or we can say cutout. This cutout, if you fold again, then we will get this cube. Now let us move to the lesson boxes and sketches. Sweet boxes. If you ever visit hotel or bakery, you can see this kind of box. If you unfold this, then it will become look like this. So we'll study the lesson properly, then you will know what is nets and what is cases and what are boxes. Let us read this paragraph. Ramaya went to buy sweets. The shopkeeper took a paper cutout and quickly made a lovely pink box for sweets. So before, this box was like this. This is called cutout. So from this, the shopkeeper made a sweet box like this. Look at the photo and make your own box. Use the cutout on the page 201. How fast can you fold it? So in page number 201, you will get some cutout like this. At home, you try to make their boxes. After coming home, unfolded the box. She removed the extra flaps so the cutout looks like this. So when she came home, she unfolded this box. Then she got a cutout like this. From that, what she has done, she made 4 more shapes like this. Each is to be folded along the dotted lines. You can see the dotted lines here. If you will fold along the dotted line, again you will get the box. So you have to find out which of these can be made into a box. I have already tried that among all these cutout, from this A and C, we can make a box like this. So you can make some other cutout also, and you can try to make some more box like this. So I hope you will try at home. Now let us move to the next page. Shapes that fold into a cube. You know, this is a cube. So Buddha want to make a paper cube using a square sheet. He has a square sheet, so from that he want to make a cube. He knows that all the faces of a cube are square. I have already explained. So he draw 2 different shapes. You can see this 2 different shapes. From this, if you fold along the dotted line, then you will get a cube. How many faces does the cube have? We know that cube has 6 faces. At home you can try. I have already explained you. And from these 2 cutout, we can make box. Now let us move to question number 2. Will both these shapes fold into a cube? Yes, you can try this at home. We can make cube of these 2 cutout. Draw at least 1 more shapes which can fold into a cube. So here you can see this cutout I have made for you. At home you try to make a cutout like this and fold it, then you will get a cube. What will be the area of each face of the cube? We know that each face of a cube are look like a square. So the area of a square is side into side. So the area of each face of the cube will be side into side. Now let us move to the next question. Draw one shape which will not fold into a cube. Here I have made one more cutout. You can try this at home. If you try to fold it, then you will not get a cube. So this is the cutout of a cube which is cutout which is not a cube. Now next question. Look around and discuss which things around you look like a cube. List a few. So here is the answer. Dice, chalk box, Rubik cube, etc. These things are look like a cube. Now let us move to the next question. Shape for an open box. What is open box? Remember the puzzle with 5 squares in chapter 3. We have already learned what is there in the chapter 3. You can show 12 different shapes made with 5 squares. in page number 46. If you cut those shapes and fold them, some of those will fall into an open box. Box without a top is called open box. Box without a top, the top side faces will not be there or top side lid will not be there, then it will call a open box. Now you can see this box, the top lid is not there, so this is open box. If bottom face also will not be there, then it will not be a box, it will become a hollow. So the bottom face must be there, only top face should not be there, so that we will call them open box. So you can see this all box which can be folded into open box, this cutout you can see here. So find out which of the other 8 shapes on page number 46. You go to page number 46, then you will see there are some cutout like this, and from there you have to find that can be folded to make an open box. I have already gone through that. So 1, 3, 5, 7, 5, 6, 7 and 8 can fold it to open box. You can try at home. So draw more shapes which will not fold to make an open box. So here 2 cutout I have drawn, it is cannot be fold into open box. Now let us move to the next question, boxes and boxes. All boxes are not cubes. All boxes are not cubes. You can see these boxes are not cubes. Here are some different kind of boxes. Match the shape on the left with a box into which it will fold. You can see these are the cutout of these shapes. So from which cutout we can make which shape, so that we have to tell. So here I have mentioned this is A, this is B, and this shape is C, and this shape is D. So here I have mentioned the cutout also, number 1, number 2, number 3 and number 4. So this A can be made from the cutout second 2. So I have matched here, you can see A will match with 2 and B will match with 4. If you fold this, then you will get this cone. So I have matched B 4, and this is C is matched with 1. So I have written here C1. If you fold this, then you will get like this shape. And the last one, this cylinder, you will get from this 3. So D is 3. So we can match cutout with their shape like this. So now let us move to the next question, floor map. So we have floor map of our own homes, even school or any places where we can see buildings, house, everything. For every house or every school, for every things we have a floor. So you see this floor map. By looking at the floor map, we can say which is the front side of the home and which is the back side of the home, or where is the windows, like that. See, door we always keep in the front side, so this is the front side. In the front side you can see 2 windows are there, this and this, and this is window in the back side, and this is in the left side, you can see the window. So for making a house, a floor map is first made. For making everyone's home, first we should make the floor map. So have you ever seen a floor map? If you not seen, then you can see here, this is the floor map. Here is a floor map of Viva's house. This is the floor map of Viva's house. It shows where the windows and doors are in the house. I have already explained windows and doors. So which is the front side of the house? I have already told the door this is the door, so this will be its front side of the house. How many windows are there on the front side? There are 2 windows on the front side. So from this floor map we can make this house. You can see this is this house, you can see here. Which one is Biva's house? So this is Biva's house according to this floor map. So these 3 are not Biva's house. So you can see, why do the other 3 deep drawing not match the floor map? Discuss. So these are the deep drawing and this is floor map. If we have a floor map, then we can draw the deep drawing of the house or deep drawing of the school or anything. Only we need a floor map. So this is the floor deep drawing of this floor map, but these 3 are not. You have to discuss on this question that why these 3 deep drawings are not Biva's house. So you try this at home. Now let us move to the next question. So here also we have a deep drawing and this is a floor map. You can see practice time. This is the exercise from where we have to answer. Look at this floor map of a house. Make doors and windows on the deep drawing of the house. From this floor map we can see where is the window, and we have to make the windows and doors in the deep drawing. So one window will be in that side, and one window will be this side, and one will be here and one will be here, and door is in this part. So are there any window you could not show on the deep drawing? Circle them on the floor map. Are there any window you could not show on the deep drawing? Yes, we can not show this window in this deep drawing because it is that side. How we can draw that? We cannot show this deep drawing. So yes, there are 2 windows which cannot be seen on the deep drawing left wall. You can see this and this we cannot show. Here how I will draw this window in this part? You can see it is inside this deep drawing. So here also this window I cannot show in this deep drawing. So try to make a floor map of your own house. This is your homework. You will do at home. You try to make a floor map and try to make a deep drawing from that. This is your homework. Now move to the next question. A deep drawing of a cube. This is a cube. From this cube we can make deep drawing of which one? From this cube you can see we can make a deep drawing of this. This is also deep drawing of this cube. But this was not a deep drawing, but this is a sample of a deep drawing. But by drawing these lines we can make deep drawing of this cube. So it was like this only, but I have drawn these lines here like this, then it's become a deep drawing of this cube. So let us read the question. Which of the drawing look correct to you? Discuss. These 2 looks correct to me. So this is the answer, D and E. Can you add some lines to make drawing F? In the F, if you will draw some lines into a deep drawing of the house. Yes, drawing F can be made into a deep drawing of cube by adding some lines. So here I have added some lines and then I got the deep drawing of the cube here. So here you can see this is the cutout of a cube or dice. You can see here. From this, which dice we can make? Which of these are correct deep drawing of the cube? This cube, A, D and E is the correct deep drawing of this cube. So a simple way to draw a cube. How we can draw a cube? We know the faces of a cubes are like square. So first of all we have to draw a square. On the square, one more square of same size, length and breadth, and we should draw the vertex like this. Then we get a cube. This is the easy way to draw a deep drawing of a cube. So here it is shown. So we can draw deep drawing of cuboid also. We know that the cuboids are made of rectangles. So if you want to draw a drawing of a cuboid, first you make a rectangle like this, and over it you draw another rectangle of same length and breadth and join the vertex like this. Then you will get a cuboid. So now you can see this bridge of matchboxes. This matchbox, if you see from the top, it will look like this, only the top part. You can see here Naveen and Pratigya made drawing of the bridge. This is the drawing, this is the bridge, and they have made the drawing of this bridge. It is look like this, and this is, she made the drawing of the bridge from top side. It is like this. And here is the question. You can see, if you look at the bridge from the top, how will it look? Choose the right drawing below. So from the top, if you see this, it will look like this. And now you can see this picture. This is also a bridge. So from this we have to make drawing to show how this bridge will look. So from top it will look only this part only. This part upside you can look like this, and front side will, from the front if you look it will look like this. You see these match boxes here and these two boxes here. One more we should add here, and this the upside part. It will look like this. So here the front side top of a bridge has given, from front of a bridge has given, and from side also how it will look is given. From this you have to make a bridge like this, or what bridge we can make from these things. Now let's move to the next question. How many cubes are needed to make this interesting model? You can see this is Rubik cube. Some of the small cubes missing from this. So if you look at this from top, it will look like this. This part only we can see from the top, and from side if you look at this only, you can see this part. This is from the side, so this will be correct.